Hi, good morning, everybody, and welcome to this third webinar of the BIM4Ren project. I'm Pierre Bourreau. I'm an RTV project manager at Nobatek in the 4. Today we're going to speak about creating BIM models for existing buildings. But in the previous webinar, we already spoke about creating a geometric model. And today we're going to see how to enrich geometric model with more information. So a few words to start and introduce this webinar. First of all, some recap about the BIM4Ren project, the philosophy and its concepts. So basically, we have a 3-step workflow that we are implementing. First, in the first step, we are collecting as much data as we can on the existing building. So in a renovation project, you want to create a BIM model of the existing building, and that's quite different from creating a BIM model of a building that doesn't exist yet. But fortunately, you can have a lot of information. You have a lot of sources of information, and that's what we're going to speak about today. So you want to create a geometric model, but then you want to enrich this with some data that are relevant for your study, and in that case, in the study of the energy performance of the building and its renovation scenario. So you're collecting a lot of data, and then you're structuring this data to create a model that you can then use for your renovation project. So at this second step, you want to consolidate the model, you want to validate it, and to ensure that it's usable for the rest of the project. Once you have the model of your existing building, you will start playing with it to design what the renovation project will be. So you will play different scenarios and compare those in terms of energy performance, in terms of costs, and different criteria that you can have. So that's the data-driven design phase. So in the previous webinars, we already had 2. The first one, it was a kind of detailed presentation of the context, the philosophy, the partners, the challenges that we're addressing within the BIM4Ren project. So a really introductory webinar. And in the second one, as I said, we presented different tools that we are using to create geometric models. So for instance, there is one tool that we're using to level up 2D layouts into 3D models, different scanning tools, some really simple on smartphones or tablets, and other which are more heavy and also more precise, let's say. And we spoke about point clouds, about BIM geometry, and so on. So if you want to watch those webinars, you can visit our YouTube channel. So look for BIM4Ren project on YouTube, and you will find the videos, the recordings of the previous webinars, and also some more videos presenting some of the tools that we are developing. Now, our starting point today is that we're able to create this 3D model, but what makes BIM attractive and interesting is that BIM is not just a 3D model. We are able to create 3D models of buildings for quite some time now, but BIM is quite different because BIM is much richer than 3D. You have a lot of semantic information in there. You can have information about the insulation layers, about the type of glazing that you're using in the building, and so on. So a lot of information. And something quite important, I think, as well in our BIM4Ren project is that we are considering BIM as a process to exchange information. I think it's something really important, because if you're the tools, the digital tools, and the BIM model that you're creating is here just to support this methodology. And the methodology is there to be more efficient in your daily work or in your project. So just a key message to deliver at that point. I think that it's also important for everyone who wants to use BIM or is wondering whether he can. I think it's important to say, okay, everyone can use BIM, because it's not just a 3D model, it's not just complex models. You can be a BIM user just having an Excel file, for instance, and just exchange the information that you have with other partners at the right time. So yeah, I think it's important. So back to our question today. So we have a 3D model, and now we want to enrich that one with more information. The key question is, what are the data that I want to have in my model? So yeah, having a BIM model is not a goal in itself. I want my BIM model to be yeah, to help me in my work. So I wanted to have the information that I really need for my project. And once I identify this data, it's how I can collect this information. So today we're going to speak about energy renovations. So of course, in energy project, energy-related project, what we are interested in is to collect the information related to the energy efficiency of the building, and all these data that are valuable to run energy simulation, like part of the geometry, but also the U value, insulation layers, thermal resistance, set points, and so on and so on. So the main focus of the BIM4Ren project is on these properties, but we are also looking at other indicators that are quite key to start a renovation project, like the cost, and also we are looking at other environmental indicators like LCA. So now we were able to identify the data that we need, and how are we going to collect this information? In the previous webinar, we presented a tool developed by the CSTB within the project. It's a BIM viewer, and this BIM viewer can be connected to a catalog of objects. And yeah, with this tool, you're already able to enrich your model, because if you have the reference of the different elements that are already installed in your building, you can just import those into your BIM model, and you get all the properties that were delivered by the product manufacturing within your BIM model. So I think it's to me another quite key message is that yeah, if we have rich product models, then it's way easier to use a BIM model. And it's quite key, I think, for the future of BIM to have manufacturers digitizing their products and delivering rich BIM objects of their different products, because most of the properties that you need for the different usages that you have on your BIM model are within the products. So take a look at some initiatives like the BSDD within Building Smart. People are working quite a lot of these product definitions. So now, okay, so we have already some tools, but it's not that easy to know how we can create those catalogs, because often products are not already digitized. And also you can collect information not just from these catalogs, but from other sources. So you can have a lot of documents related to your buildings, past renovations, and what kind, yeah, also the references of the systems that are installed can be found in textual documents. You can also go on site and make some visits, like for the energy audit, but you can go on site and collect information related to your building. So that's exactly what we're going to speak about today. And we will have 3 persons speaking about that. So Oliver Schulz from the University of Aachen will first speak about image acquisition on site. Nathalie Charbel will present Massdoc, which is a tool to extract textual information. And Julia Barbano from AES will present a tool that scans energy bills to get more information about the actual performance of the building. So now giving the floor to Oliver. Also, I take this opportunity to tell you that if you have any question during the presentation, just use the board on the GoToWebinar to ask your questions, and we will answer them at the end of the presentations. So yeah, I think Oliver, you're now a presenter.
Yes.
Yes. Okay.
Okay. Can you see my screen?
Yes. Perfect.
All right. So I'm going to show you now CAIA, or context-aware image acquisition. It's a workflow about how to image document existing buildings, and it's part of my PhD studies as a PhD student at design computation at RWTH Aachen, where I'm doing research on connecting building information and data from heterogeneous sources. As I said, this is focusing on image documentation, and nowadays when we are doing this process, it normally leads to a huge collection of data. So we create so many images during this process, and when you later on want to find a specific one again on your hard drive or on a cloud, it's often very hard to find this one. Moreover, there are more issues. For example, it's not always clear when you look at an image what exactly was the intent of the image. So what did you want to say with it? What was the issue here? Or another issue is that you don't always know where this image was taken, because when you have a very detailed picture of a corner in your building, it could be more or less everywhere. And the issue with this is even, so for me, it's sometimes hard to understand this, but it's even harder to understand this for people who didn't take the picture. So the overall goals here are an easy retrieval of images with different search parameters. You can see it here on the right. I show here's 2 example queries, like something like show me all pictures of this window before it was renovated, or show me all pictures where this wall is seen. And I want to add this whole process of documenting with images to the BIM methodology. What do we need for this? There are some prerequisites we need for this, and the overall goal here was to be very low tech. So I didn't want people to use some heavy scanners or so on, which are very costly, but just to use, as you can see it here on the presentation, just a 2D plan of your building, or maybe even just a part of your building, and a mobile application which is AR capable, which is nowadays most of the mobile phones which can come to market. And moreover, you can use, it's optional, a BIM model, but of course, when you want to link this process to a BIM methodology, then you need a BIM model. But parts of this process are not dependent on it. And I'm going to show you in a minute how exactly this whole process works in a few short videos. But first of all, I want to present you the infrastructure around this whole process. So there are 3 main parts. The first of it is the image acquisition application for mobile devices, which is used to create images as you're used to with your normal mobile devices. But the special thing here is that during your capturing of images, you are tracking yourself on a 2D plan, so that the location and rotation and so on where you did this image is saved. And then this is synchronized with the BCF server, which is in the middle of this whole process and which is communicating between the different parts. And moreover, there's an IFC viewer, which is used to first of all review the images. You can later on link a BIM model to this viewer, and it's also used for the plans at the beginning, which I'm going to show you in a second, to load them into your viewer first and then scale them to the right size so you can use them in the mobile application. Yeah, and this is what I'm going to show you now. So first of all, at the beginning of this process, there's initial setup, as I said. So first we have to choose a 2D plan and load it to the viewer. And when you load a picture or a PDF or something like this to a viewer, it's just pixels, and pixels don't really have a size. So first of all, what we have to do is we have to measure a certain distance in this plan and then tell the viewer what is the exact measurement of it. It's quite easy when you have a dimension here, but you can also do this with doors and something like this. And this whole process is very similar to what Plans to BIM does, which you can see in our second webinar. So as soon as you've scaled the plan, so it's in a 1-to-1 scale, we upload it to the BCF server, and now we can use it on our mobile application. And here on our mobile application, first of all, we have a BCF server, so we have to log into the server. And here we can select a project we want to track ourselves in, and a document. And with document in this case is meant the floor plan or the part of the building we want to track ourselves in. As soon as you have selected these, we can go to this next view, and here we have to choose our initial position on the 2D plan in the building. So what we have to do is we have to tell the application where we are standing in the real building right now. And so this position is getting synchronized with the position in our mobile application as a starting point. We can also rotate our camera so that the direction we are facing in fits as well. And as soon as this is okay, we can just hit the start button and track ourselves in the building. And now the application looks more or less like a normal camera mobile application. So you can create images. You have a little gallery here, and there is a circle which you can see here, which is responsible for showing our position in the building right now and showing us if the tracking is working as well. So you can, during the whole process, when you walk through the building, you can see where you are standing right now in this little circle. And then you can create an image, and you can attach information to this image. So sometimes it's not necessary, but sometimes you want to give this a title, you want to add a comment. You can also assign this to a person, maybe to give work instructions or something like this. And this can be done here for each image. And this is all based more or less on the BCF standard, which is a building smart standard. And now, as soon as we added some information, we can review all the images in a gallery. We can also edit images, and we can add new information to them, and then upload them to the server. We can also download them from the server, so when there is a change from another software application somewhere at the information level of this image, we can also get this information updated here. As soon as this is uploaded to the server, we can use our viewer, as I said, to review those images. So I'm going to show this in a little video here. We first log into the server, select project again and the document. Then the 2D plan is getting downloaded to the viewer. And now what we want to do in this example is we go to this corner and we want to write a query to the server where we ask the server, give me all images in a 200-centimeter radius around my camera position. Then we hit the search button. And now you can see on the right side, the images are getting downloaded, and you can also see the exact camera positions of the images on the 2D plan. So, and you can, of course, review these images in detail, and you see that you can teleport to the location on the 2D plan where this image was taken. So you can know exactly which location we are talking of right now. So now we have a connection from the 2D image to the from 2D image to the 2D plan. But as I said, I want to connect this process to the BIM methodology as well. So, and when we want to do this, we first of all have to match the position of the plan, because right now when you first initialize the project with a 2D plan, it doesn't really have a location which matches with anything. And what we have to do now is we have to change the location of the plan just with a little slider here. We can adjust it and see that it matches with a BIM model we've imported into this viewer as well, and then upload it back to the server. And as soon as this is getting uploaded, all the images and all the information we added to this is getting synchronized as well. So they get an update on their location. And now on the last video, when we download these images again, now I just write a query where I want to download all. You can see that their position now matches with the position in the BIM model, and now we can use this to, for example, write queries like give me all images which are seeing this wall, and we can also add this with dates and so on. So now we have a connection to a BIM model. But you can also see that this whole process I've shown you now works without the BIM model at first. So we can integrate people without having to work in a BIM model into the whole BIM process with a workflow like this. So, and the use case I've shown you now was just a regular image documentation, but of course there are some additional use cases. And when we, for example, talk about an energy audition, we can add more tools to this application which are specific for this energy audit, or we can do this with a structural engineer and so on. So we can advance this tool to be more specific for different use cases. Moreover, another use case is that with this tool, we could, for example, enable residents of buildings to participate in this whole process. So they, for example, could use something like this, an application, make an photo, an image of a damage, and then can attach this to the facility manager, who then, as a third use case, could use this information and create a work instruction, for example, for a construction worker and so on. So he can immediately see where he has to go in the building, where he has to fix something, and what is the issue there. Yeah, and this is basically all. Thank you for your attention.
Thank you, Oliver. Thanks for the presentation of the tool. So we just saw this tool as a helpful one to go on site to take pictures of the building, and it can be used, for instance, to assess the performance, or to have proofs of evidence of damages on the building and so on. So it's something to assist the energy audit. And use cases are quite huge for this one. Once again, if you have questions about it, you can use the question board on GoToWebinar, and have your questions in there. So now Natalie Charbel will present the Massdoc tool. There you go, Natalie.
Yes. Hello, everyone. So I'm going to present the Massdoc tool, which is a tool for semantic annotation. Yeah, for semantic annotation and information search over textual documents. So let us first explain why do we need textual documents in the context of renovation project. So nowadays we have many advanced tools in order to get the data, or for data acquisition of existing buildings. So for example, we have the scanning tools, which can automatically generate BIM models. So these models may contain geometric information, such as the width and the height of the windows, but not functional properties, such as the U value of windows or the thermal transmittance, which could be very important for energy simulation activities. So this information is usually found in various on-site and off-site documents, for example, technical documents, audits, interventions, and so on. So we basically need to have a solution in order to help the user to extract this information from these documents and accelerate the BIM enrichment, the BIM enrichment process. So this is quite challenging because these documents can have various formats, could be of various pages. They could also have links between them, for example, a reference between documents. And also we have the issues of the vocabularies used in order to describe the same information. For example, if the user wants to search for the U value of the windows, the U value could be described in several documents using different vocabularies. For example, the thermal transmittance term could be used. Also, we could have the U factor term describing the same information. So the Massdoc tool is going to help the user in order to overcome these challenges combined, so as to reduce the gap between the BIM models and the existing textual documents. So the end user could, through the Massdoc tool, use the semantic annotator, which can restructure these documents and identify potential IFC entities within the text. It can also locate potential IFC entities within the documents. So for example, we have information on the page containing these entities and the relevant sections of the document, while also handling the semantics of words. So once the documents are annotated, the user could use the search engine of the tool, and from the results that the tool returns, he can better understand his query, and of course, it will help him to enrich the BIM model. So what's the main difference between the Massdoc tool and existing tools? The Massdoc tool is in between the BIM-based solutions, which focus on the BIM information and completely neglect the documents aspect, and the documents management systems, which completely neglect the semantics of information and only focus on offering classical operations on documents. So now I'm going to show a demo of the tool using two documents. So the documents here are in French, but do not worry because I'm going to explain what is going behind the scenes. So here we have a technical report, a thermal report. It's a Word document of 46 pages describing several information. For example, the glazing, the thermal bridges information, and so on. So the first difficulty is in locating relevant information inside the document. So for example, if the user is searching for the solar factor of windows, we need to locate the relevant section of the document describing the solar factor. So here we are locating the table among many irrelevant other sections. The second document is a technical document, which is 75 pages, describing also several topics, including functional properties of windows. So this document should have relevant information on solar factor. Although solar factor term does not exist in the document, we can have this information described using different vocabularies. So here, for example, this section is talking about the FSW coefficient, which is equivalent to solar factor. We also have the term glazed frames, which also refers to windows. So this is challenge 2, handling semantics of words. In this section, we can also encounter expressions referring to other documents, which may contain relevant complementary information on the solar factor. So we need to handle references between documents. We need to analyze these expressions and locate the relevant reference document. So now I'm going to show how the Massdoc tool can accelerate and help the user in searching for the relevant information over these two documents. So this is the web application of Massdoc tool. There are two modules. The first one is the semantic annotator, which is a prerequisite for the search engine. So in the semantic annotator, we can choose to annotate one or several documents at a time. We can also choose the language of these documents. So here, for example, we are dealing with French documents. So the annotation process has started, and it may take few minutes depending on the complexity of the documents, their size, the dependencies between them, and so on. So it has done successfully. Now we can annotate as many documents as we want, but here I'm just going to show one example. But of course, we have annotated other documents as well. So now we can use the search engine interface. The user can type his plain text query or choose one of the predefined queries. So here, for example, the user is writing in French his query, which is SW coefficient of opening elements. So he needs to know everything about SW coefficient and opening elements and related terms as well. So here are the results of the search engine. So these are innovative results. Why? Because we are returning parts of documents and not the entire document. So we are helping the user locating the relevant information inside the same document. So if we click on one of the results, we can navigate directly to the table, for example, containing the relevant information to the right section. So we are basically satisfying challenge one. We also handle semantic offers. For example, here, one of the results was about the bay window and solar factor of bay windows, which are terms related to opening element and SW coefficient typed by the user. We are also providing contextual information. For example, the document title, references if they exist, the relevant text. The results are ranked according to relevance with respect to the query. So here, for example, we are showing a less weighted result because it's pinpointing a section describing opening elements and not solar factors of opening elements. And finally, we will show you an example of how can we resolve reference between documents. So one of the results is referencing another document. So here we have a dynamic link. So the user can, of course, click on it and directly open the relevant document. So we are satisfying also the third challenge. So this is quite all what I wanted to show about Massdoc tool. And thank you for your listening. And I'd be happy to answer your questions at the end. Thank you.
Yes, thank you, Natalie. So the Massdoc tool to extract information from text, and you can see two use cases in the project, in the BIM4Ren project, where we want to create BIM objects of products from technical files of describing those products, and also another one would be to have a kind of a helpful tool on top of Croquis, which is a collaborative platform, and the more textual files you have within the project, the more you can use this tool to look for the information that you need. Okay, so now the floor is to Julia from AES, who will present the utility bill reader.
Yes, thank you, Pierre, and good morning, everyone. Yes, I will close this series of presentations with the third big problem in preparing for an energy renovation of a building. So after seeing the parsing the images and making sense of looking at the building, and parsing the documentation and finding things in the documentation, the last big problem is dealing with the utility bills. And this is a fundamental step of renovation, is to understand how the building performs, because this is the first thing we need to do before we take any decision on what should be the renovation strategy. So we need that data, and we need it to be usable. We need it to be data that we can parse and we can use for further analysis. However, the reality is that this kind of data right now comes in a form of paper documents. It's information that comes from tenants, from building apartment owners, etc. It's very, very difficult to get in a consolidated form, and most likely what it ends up being is an extremely frustrating process where it's very difficult to cut through the noise and process the data manually. And there can be a very high risk of errors, a very long process of getting this information. And so for this reason, what we have been working on within BIM4Ren to solve this is the utility bill reader. And I will walk you through the various components of this result. This is a cloud service that reads utility bills and processes the data automatically, and it recognizes whether it's a gas or electricity bill, recognizes the provider, and so on. And I will show you this through an interface now, but as a cloud service, this is a API. There's an API available for it. So this is part of the integration within the BIM4Ren solution, where we try to have all tools that can talk to each other and exchange data as needed. So quickly here, how does this work? So the first thing the user does is to choose a bill to upload. It has to be a PDF, yes, but it can be either a PDF downloaded from the utility. This is becoming more recent, more common in recent times, or it could be a scan from a paper bill, which is still the majority of cases. Then the service takes a while to read the bill, a few seconds. And when this is done, it shows a message that says the billing details have been extracted and asks the user to check the results. This is very important, this step, because while the service is very accurate, it's also important to make sure that the user can make any corrections as needed. So to do so, then the service shows a comparison of the images from the bill and the text that has been extracted. So the information that is included here is the billing amount, the billing period, and the usages. Especially, this is especially relevant if there is a split tariff by time, which is quite common for electricity, for example. So if any of those readings are wrong, then the user can just correct them in the editable fields. So once this is done, the simplest thing that the user can do is just download the results as a CSV file. And this is if the user wants to do local analysis, this is fine. But in view of a linked data environment and a broader process, what the user can also do is connect to iScan. And iScan is IES's data management platform, which can handle time series data from multiple sources. It's used to organize data for advanced analytics and insights. So to connect to iScan, the user just needs to provide the connection details to connect to the API. So what is the name of the project, of the building, and the API token. This is the access that allows the user to post the data, of course. And then where should the data be sent to? What is the channel? What is the time series that needs to be fed? And then the data is sent to iScan, and I will just show you quickly here what this looks like. This is the iScan UI. And you see here the data in red, these bars in red are the utility bill reader data. And you will notice these are now shown monthly, while, as you know, the periods of utility bills is usually a couple of months or even more. So the data that is red on the billing periods is rescaled automatically to monthly values. And then this makes it easy to compare it with other data that is available in iScan. So, for example, data that is generated from a machine learning model or from an energy simulation, and furthermore, other data, like, for example, the weather information that is linked to the building in iScan. And this can be also very useful for energy modeling purposes. Then all of this data is available via API. Much like there's a token to access and send data to scan, there's also tokens to get data from iScan. So this means that this information can be used in a linked data environment, which is crucial in the BIM4Ren ecosystem. So to simplify then, what are the main innovations of the utility bill reader? It has three main advantages over manual processing. The first one is that it is fast with human supervision. So on one hand, yes, the parsing is automated, but supervised, and this minimizes the risk of errors. It makes the process almost foolproof. It's a very flexible system because there's no need anymore to process all the data at the same time. When the data is stored in iScan, as I said, the data is rescaled and set over the various time periods. So it's possible to add data over time. When new bills become available, that data persists there. So as you gather more information, you just continue enriching the information that you have on the building. And finally, it minimizes privacy risks. The way the reader works is that it parses the bill just to detect the minimum data that's needed for energy analysis. So the dates, the consumption, and the cost. And once this data is parsed, it's sent to iScan or downloaded locally, but all other data in the bill is discarded, and we don't store the image of the bills. So in this way, we can minimize the data. So this follows the data minimization principle that is part of personal data protection requirements, like in GDPR and so forth. So it makes it also a safer, a more secure way of handling this data for renovation. And that's all on my side. And if you have any questions, we'd be happy to answer them.
Thank you, Julia. So time to conclude. Okay, so a few words to conclude this webinar. Okay, so we just saw three of the tools that we are using to collect additional information and not just geometric information from the existing building. But in the project, we're actually developing more data that can be used in that phase of the data collection phase. So there is the GIS to IFC tool by Technalia. With this tool, you can rebuild the context of a building, and that's important to get some information about external masks that, of course, have some influence of the energy performance of the building. And this is done, basically they are extracting information from some GIS sources. There's also the HVAC to BIM by WiseBIM. So we saw the WiseBIM tool in the second webinar as a tool to get the 2D layout of a building, and from this 2D layout you could get an IFC geometric model. With this HVAC to BIM tool, you can do something quite similar, but on the HVAC network, and so recreate a MEP infrastructure of your building in an IFC format. There's also the short-term fault detection and diagnosis by Fraunhofer Institute. So on that one, basically you install some IoT sensors, and this can be helpful for the energy audit. So you can, at the audit phase, you can install some sensors and try to get some diagnosis about the way the different HVAC system works in your building, and trying to detect some things that are not working properly on those systems. And finally, there's we have some online questionnaires, and we are trying to integrate the occupants and the managers of the buildings inside the process, so they can tell us about problems that they really live with in the day-to-day basis in the building. So Oliver showed that CAIA tool can be used by occupants, but yeah, we are also trying to collect information from occupants in a different way through questionnaires. And this is performed by the University of Vilnius and EDF. Okay, so BIM enrichment, that's exactly what we saw today. Yeah, you have many relevant sources of information in a project. So all the tools that we saw today are there to support this BIM enrichment and to collect information from the sources that we identified. But in your projects, you need to identify data that you need and then the sources that you need. And then, yeah, again, the tools are just there to support you in your work. In BIM4Ren, we are looking at energy, FCA, costs, basically, and this can be extended. The tools we are presented are can be used for the creation of a BIM model, but also as we saw in the energy audit phase, which is so something that can be coupled with the creation of a BIM project, of a BIM model when you use BIM in a renovation project. Yeah, we distinguish tools also on whether we use them on-site or off-site. So going off-site is always necessary to get some information of your building, but you already have a lot of information off-site, and it's good to have tools that can help you there. And something quite important, I think, is that the role of a BIM modeler is still crucial, because we saw all those tools here, but the way to automatize the extraction of information and put that into a BIM model, it's yeah, I wouldn't say it's safe enough now. So we are using a lot of AI to extract the information, and when you speak about AI, there's always the notion of accuracy of the algorithms or the methods that you're using, and AI systems are not always 100% efficient. So the way we envisage the use of these tools is more as a tool to help the BIM modeler in his task, so that he can extract the information from the different sources and put that in the correct place in the BIM model. Yeah, again, another key message. I think there's not one BIM, but potentially as many BIM as project, and you need, every time you want to have a BIM project, just start by identifying your needs. So the needs is what will you use this BIM model for? So, and that will help you to identify the data that you need and tools that you need to assist you. So here we are speaking about energy efficiency innovation, but you can, if you want to have a BIM model for the maintenance of the building or other kind of usages, start thinking about that. Okay, so time for question and answers, if you have some. Just to let you some time to prepare those questions. I take the opportunity to tell you that, of course, we have a website, BIM4Ren.eu, so go there, visit it. And on this website now we have also a new page for the stakeholders community. So if you want to follow up the project, to get more information, perhaps also to test some of the tools that we are presenting, then go there, sign up, and we'll let you know how you can be involved in the project with us. And also, of course, we are on Twitter and LinkedIn, so you can still get information about the project and its progress there. Okay, so that's everything on my side. We no questions yet so far. So guess this was all clear for everyone. So yeah, if we have no questions, again, stay in touch with us. Go to the different media that we are presenting, and we'll continue our series of webinar to present the project and the progress. So I think that the next one will be about how we structure all the data that we are able to collect into a model that we have created, which is not exactly IFC, but kind of different. So we will speak about that, and then how we can use this model for renovation, playing scenarios, assessing their performance, and so on. So thanks again for being there, for listening to us. Stay in touch, and thanks a lot to Julia, Natalie, and Oliver, and so RTM Solution, who provided the platform to present the webinar today. And yeah, see you soon for the next webinar. Bye bye.